The feeling begins not with a sneeze, but with a molecule, histamine. When Sir Henry Dale first isolated it in 1910, he saw it as a simple biological amine. Yet, this molecule lives a double life. In your brain, it's a neurotransmitter that helps keep you awake. In your stomach, it commands the release of acid to digest your food. But for this story, histamine is a prisoner, stored in microscopic granules, waiting for a signal. The prisons holding histamine are called mast cells. They aren't circulating in your blood. They are stationary guards embedded in the tissues that meet the outside world. They line your airways, your skin, and your digestive tract. Think of them as silent sentinels posted at the borders of your body, packed with hundreds of these histamine-filled granules like tiny biological grenades. Their job is to wait for very specific intruders, and they can wait for years. The system becomes armed during a completely harmless, unnoticed event. A single grain of pollen, for instance, is inhaled for the first time. Your immune system's B cells inspect it and misidentify one of its proteins as a threat. In response, they manufacture millions of specialized Y-shaped antibodies. These are not just any antibodies. They are a specific class known as immunoglobulin E, or IgE. Each IgE molecule is custom-built to recognize and bind to that exact pollen protein and nothing else. These newly forged Ig antibodies travel through your tissues and find the mast cells. They dock onto the cell's surface, sticking their tails into specialized receptors, leaving the Y-shaped arms facing outward. A single mast cell can become bristling with up to 500,000 of these Ig molecules, each one a tripwire for the same allergen. The cell is now sensitized. It is a silent, microscopic landmine waiting for the one specific thing it has been programmed to detect. Now, imagine that same type of pollen enters your system again, days, months, or even years later. It drifts through your airways and bumps into one of these armed mast cells. A protein on the pollen surface is the perfect shape to be grabbed by the IgE's arms. But it doesn't just bind to one. The allergen acts as a bridge, physically linking two adjacent IgE antibodies together. This cross-linking action is not a chemical signal, it's a mechanical one. It's the physical act of turning the key in the lock. The instant two Ig molecules are pulled together, it causes a conformational change in the mast cell's membrane beneath them. This change rips open nearby calcium ion channels. In a fraction of a second, calcium ions, which are far more concentrated outside the cell than inside, flood into the mast cell cytoplasm. This sudden, overwhelming influx of calcium is the irreversible command. It is the final authorization to detonate. The calcium flood triggers a cascade of internal signals that tell the histamine granules to move. They swarm towards the inner surface of the cell membrane. Through a process called exocytosis, the granule membranes fuse with the cell membrane, becoming one. This fusion tears open the granule, violently expelling its entire payload of histamine and other inflammatory chemicals into the surrounding tissue. This explosive process is called degranulation, and it happens within seconds of the allergen being detected. This sudden cloud of histamine immediately begins to wreak havoc. It binds to H1 receptors on nearby cells. On the tiny blood vessels, it causes them to dilate and become leaky. This leads to redness, swelling, and a flow of fluid that becomes a runny nose or watery eyes. When histamine hits nerve endings, it creates the maddening sensation of an itch. In the airways, it causes smooth muscles to constrict, tightening the passages and making it difficult to breathe. But why? Why does such a sophisticated defense system launch a full-scale assault against a harmless speck of dust or pollen? The sheer violence of the response seems utterly disproportionate to the threat. It's like using a sledgehammer to kill a fly. The answer is that the sledgehammer wasn't built for the fly. It was built for something much, much larger that, for most of us, is no longer there. This entire IgE mast cell system didn't evolve to fight pollen. Its original, and arguably primary purpose, was to fight off infections by parasitic worms, like helminths. For most of human history, these were a constant threat. The hygiene hypothesis suggests that our modern, sanitized world has largely eliminated these ancient enemies. Our immune system, honed over millennia for a specific kind of war, now finds itself unemployed. It is a powerful army with no one left to fight, becoming restless and prone to mistaking civilians for enemy soldiers. The misidentification might be more than just random. The theory of molecular mimicry proposes that certain proteins on harmless allergens share a similar three-dimensional shape with proteins found on parasitic worms. A keyhole on the IgE antibody, perfectly shaped to recognize a worm, might accidentally fit a key-shaped protein from a peanut or a speck of dust mite. The immune system isn't being stupid, it's being tricked by a resemblance. It sees the shape of its ancient foe and launches its ancient, powerful defense. So, an allergy is not a sign of a weak immune system. In many ways, it's the opposite. It's the ghost of a powerful and effective weapon, echoing through a world that has profoundly changed. The sneezing, itching, and wheezing are the sounds of a biological defense system fighting a phantom war against an enemy that is no longer there. It's a system perfectly adapted for a past that we have escaped, leaving us to deal with the consequences of its formidable and now tragically misplaced power.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.